So if we talk about inertia, so first of all, the most important thing, inertia is the internal property of a body, right? So first of all, we need to know that inertia is actually related to the uh, state of a body, to the property of a body. So we can say that intrinsic property, intrinsic mean internal, right? You may also use that word internal property of a body. Intrinsic property of a body which resists the change. Okay, so we were talking about inertia. So inertia is the intrinsic property of a body, which resists the change in the state of a body, right? The daily life example or the common example of inertia is, let's take the example of a car. When let's suppose we are driving a car, so we use a seat belt, right? Because we know that when suddenly someone applies the brake, so what will happen with our body? Our body first move in which direction? In forward direction,
Backward,
backward,
forward.
forward, right? Because initially we are moving in forward direction with the car, right? So our natural property or natural state is now motion state, okay? Because we are smoothly moving in the car with the direction of car. So now our body is in a state of motion with the car. But when we suddenly applies brake, so what happens over there? When during, or we can say that when we apply brake, so there is a change of state, right? Because car changes state from motion to rest. Okay, but there is a property of a body that is known as inertia. So due to that property, our body first move in forward direction because it likes to continue to its state, that is the motion state, right? So with the help of seat belt or with the help of that dashboard, we just place our hand on that dashboard or on the steering. So we are able to neutralize our body in our natural rest state, or we can say that it is help us to change our state smoothly. So after that impulse, we first move in forward direction, then comes back into rest state. So actually, that situation when body actually moving in forward direction during the application of brake. So that specific part is due to inertia, right?
Okay.
Okay. And one more thing, if someone asks you about, because in MCQs or in theory questions, they ask about the factor affecting inertia, right? Okay. So let's suppose if there is a heavy truck, right? Driver is driving a very heavy truck, and if we compare it with the bicycle, right? So both are moving on a straight road, and suddenly bicycles apply brake, cyclist apply brake, and truck driver also applies the brake, right? So which object will come into rest uh, at the first stage, the cyclist or the truck? Which body will comes into rest state in short interval of time?
The cycle.
The cycle, because we know that the mass of truck is very much greater as compared to the cyclist, right? So it means that
Yes.
inertia also depends upon the mass. Let's suppose if two men are just running and having in a race from one point to another. So one man is of 90 kg, second one is of 40 kg. So you also know that when 90 kg wants to stop himself or herself, so he take more time as compared to the other one, right? Because of mass of a body. So actually, if they ask you about the factor, so the most important factor for inertia is the mass of a body. Greater the mass, greater will be inertia, right?
Okay.
And there are some daily life magic trick that actually usually people used to do with the help of science. So there is also there are some tricks or daily life experiment in which we can easily uh, find out the concept of inertia. Let me show you some basic experiments. Let's suppose if we observe this experiment, is it visible?
Yes.
Okay, so now we are having a conical flask, right? And a round tape or a round material is actually like a circle placed on it, right? And there is another object placed on that circular tape, right? Or circular coil. So mostly we use this experiment, or we mostly used to do this trick. You may observe that we just place a pencil in the center and try to pull this tape out, right? So that object on the top of the tape actually falls into the flask, right? So we used to do this trick also in the school. Maybe you tried or not. If you don't, if you never tried this one, so after the class you must try this one, because this is actually works on the concept of inertia. So let's see. So this is the experiment, right? We actually just pull that circular tape or circular coil. So that object which is actually placed on the circular coil just directly falls into the flask, right? That object not move with the surface of that coil, right? Why? Because first of all, object is not completely fixed with the coil, right? So, just like the example of the car, we are completely bound in a car. So we are not able to just move out from the car like this, as is this is example of inertia. So that's why the object continues a state of rest. So that's why it fall into the flask, right? There are some other examples. Let's suppose like this one, a huge coil. Again, object will move straight into the flask. We placed a coil on the paper and we just flick that paper, so coil will again move into the beaker. Now we have different masses and different beakers with paper under it, and this is also example of inertia. Body continues its state of rest, but due to change in the motion state, so or the state change of the second body, so inertia helps the body to change its position, right? This is also the example of inertia, right?
Okay.
So there are multiple daily life application related to inertia. So the daily life examples and daily life incidents are related to inertia also. Okay.
Okay.
This is the concept of inertia. Why object is falling into the flask or into the beaker? Because initially the body is at rest state and it wants to continue its state of rest, right? So that's why object will directly fall into the flask or into the beaker rather than moving with the surface of the tape, right?
Okay.
So this is the concept of inertia. Now, just quickly overview the Newton's law, because those are not much like very much important for the exam point of view, but still you need to know about the concept, that what is the statement, what are the statement of law. Do you know about the Newton first law? What is the statement of Newton's first law?
No.
Okay. So actually, Newton's first law is almost like the same as the inertia, right? But there is only a difference, that Newton law is for the body specifically, and inertia is the natural internal intrinsic property of a body, right? So that is the only difference. So if we talk about the Newton's first law, so Newton's first law states that body will continue its state of rest or motion rest or motion until it is acted upon by an external force. Right? So actually, this is the statement of Newton's first law, that let's suppose a body is placed at rest state, so it will continue its state of rest, right? Until someone just push or pull that body, right? Let's suppose if chair is placed in a room, and let's suppose someone push that chair, or someone that just pull that chair. So before that, chair will not able to change its state of rest, right? And same goes for the motion state. Let's suppose if ball is rolling on a floor, if there will be no friction, no resistive force, so ball will continue its state of motion, right? But there is resistive force of ground, there is air resistance included over there. So that's why ball or any body will come into rest after moving some distance. Okay.
Okay.
So this is the concept of Newton's first law. Or if we talk about the examples, so examples are also not much very difficult. We may just consider book lying on a table. So this is the common example, very simple example. Let's suppose a book is lying on a table, so it will remain in the rest state until someone moves that book from that place, right? And the second one is body moving with constant speed, or car moving with constant speed. Okay, so book body is moving with constant speed is also the example of Newton first law, right? So you just need to know about the statement and some daily life example, right? That is enough for Newton's first law. You don't need to study much about Newton's law, right? Because when we talk about the example, so you will also get the concept that how different applications are depending upon Newton's law, right?
Okay.
Basically, one more thing, there is a concept of external force, right? So in Newton's first law, Newton actually gives you the concept of external force, right? And in next law, he actually gives you the formula and the concept, complete concept of force, or external force, that we already studied. So according to Newton's second law, a statement will be like this. Newton's second law. Now, Newton's second law is actually related to the force, or we can say that acceleration of a body is directly proportional is directly proportional to the applied force and inversely proportional to the mass. Okay, do you have idea of directly proportional and inversely proportional?
I know the formula.
Okay, F equals to ma, right? Okay, This statement is slightly different from the formula. We know F equals to m is the main theme of second law, but the concept is that Newton's explain in Newton's second law is different. It will be like, let's suppose if we want to push any object, right? Let's suppose if we start a car, we start the engine and car starts to move from rest state. So when someone applies force on object, so there will be an acceleration in a body, right? Always there will be an acceleration in a body because body starts from rest, it starts to change its speed, so definitely there will be a value of acceleration. So that's why Newton explains with the reference of acceleration. So first of all, acceleration is directly proportional to the applied force. Acceleration is directly proportional to force. And second thing is acceleration is inversely to the mass. Okay, so this is the concept. And when we just combine the equation, so we will get the formula F equals to ma, final equation. So this is the concept of Newton's second law. It means that let's suppose if we consider an example of a trolley, right? We are having a trolley at initial stage. Uh, and we are just that in any store or any, right? Initially, the mass of the trolley is the original mass of the trolley, right? There is nothing in the trolley, completely empty. Suppose someone is just moving that trolley in a store and the mass of the trolley is equal to the actual mass of it. But let's suppose if you are just trying to push or pull that trolley, let's suppose if we try to pull that trolley from one point to another and we apply a force of, let's suppose, 5 Newton just for the reference, right? And we apply a force of 5 Newton and trolley starts to move towards right hand side. Okay, and you continue the motion and just pull that trolley from one point to another. And during that part, let's suppose someone is just filling the products in your trolley, right? So due to that filling of the products in the trolley, the mass of the trolley plus the mass of the product actually combines, and the mass will increase as compared to the previous stage, right? And the force that you are applying is now less as compared to the previous one because now trolley is become more heavier as compared to the initial stage, right? So that is the concept of Newton's second law, that now your acceleration will decrease because your mass actually increases, right? And same goes for the
So
force.
we will have to use more force.
Yes, so if you want to maintain the motion, so you need to increase your force, right? More force, more acceleration, right?
Okay.
So that is the concept, and it is more likely the same concept as the inertia, right? But that is the internal property, and in this concept we talk about the external concepts, right? So that is the only difference. Otherwise, both statements are like to be same.
Okay.
And the third law is related to action reaction force, right? That is the most easiest and the most famous law. So Newton's third law. So if we talk about Newton's third law, so in Newton's third law, the statement is very simple, and the statement is for every action. So for every action, there will be an equal and opposite reaction. right? So this is the statement for Newton's third law. And yesterday, when we are talking about the balanced and unbalanced forces, so in the scenario of balanced and unbalanced forces, suppose if we consider the rest state, so in this situation, we observe that one force is acting in upward direction, one force is acting in downward direction, right? So of the body is like the action force, right? And in the response of that force, the table also applies the reaction force in upward direction. So now book is completely at rest. It means that both forces are equal and opposite. So that's why book is not able to move. And this situation is known as, or this is the also a example of Newton's third law, that all forces are equal and opposite, right? And same goes for the body with constant speed. So when body starts to move with constant speed, so all forces are equal and opposite, or we can say that are in the balance form. So when forces are balanced, so we can say that there will be action, equal action and equal reaction force, right? So this is the concept of
Okay.
the third law. Let's suppose we know that in river rafting or in boats, the life boats or different types of boats, where we are going to raft through the river or just sailing into the water. So we use different objects to push that water backward, just like in the swimming, we use those uh, pads, just like the fish fins. So we just push that water in backward direction. So in reaction, water also applies force in forward direction, right? Just like the walking or is our in our daily life when we try to push that ground in backward direction, right? So ground will also apply force in forward direction. And again, the very common simple example, when we try to hit a tennis ball on the wall, so ball applies force on wall and wall will also repel back with some force that is known as reaction force. Okay.
Okay.
So that is the concept of Newton's third law. There are multiple examples of Newton's third law. So actually in first law, there is a concept of external force. In second law, there is a complete explanation of force, external force. And in third law, there is a complete specification with respect to the direction, right? So this is the theme of Newton's law. And after that, we now know the formula of F equals to ma. We know about inertia. We know about Newton's law. We know about resultant forces, different types of forces. Now let's try to solve some questions related to forces, because we left out some questions. And we also discussed free fall motion, right?
Yes.
So we already discussed the concept of free fall motion. So it means that we are able to solve the questions related to forces. Let's find some question. Calculate the work done. Okay. First question that we observe for the forces. There are four forces acting on a car. We already discussed this example, so this question is not much very difficult. You just need to match the boxes with the right? So, starting from the weight of the body. So, which part of or which force gives you the concept of the weight of a body? A, B, C, D.
C.
C, good. So, this will be the weight of our body. It means that C is actually with the
Force
weight of
of
a body,
gravity.
force of gravity. And the next one is force A. So, force A will be what type of force?
Contact or normal reaction force.
Normal reaction or contact. Very good. So, B, sorry, A. A is the normal force or the contact force, or in simple word, the reaction force that we already discussed. The next thing is force B. Force B is towards right hand side.
Air resistance and friction.
Forward direction. Friction will always in the opposite direction. right? Car is moving in which direction? Car is moving
Right.
towards right hand side. So it means that the force of engine is towards right hand side. Okay. So it means that B will be the driving force, and finally D will be air resistance.
Oh, okay, I get it now.
So this is the concept, right? Now you also got the clear concept how to just mark forces with constant speed and a body. Now part B. So in part B, they just mentions the value of the forces 8,000, 1,000, 8,600. So A and C are equal and opposite, right? A and C. So just mark the value. So A and C means this force is 8,000 Newton, 1,000 Newton, right? And if we talk about B and D, so B is equals to 1,000. So B is greater than D, right?
Yes.
1,000 Newton, and the backward 600 Newton. Now we can simplify this whole situation like this: 8,000, 8,000 balance and cancel out. 1,000 in forward direction, 600 in backward direction. So 1,000 minus 600 will be equal to 400, right? So resultant force will be equal to 400 Newton in forward direction, right?
Y and forward.
Yes, why in forward? Because this is force B, right? Force
Yeah.
B is in forward direction. So 1,000 is greater, right? So 1,000 is in the front direction, 600 in the backward direction. So we just minus, or we can say that we just add the forces like this, that 100, sorry, 1,000 plus. Now we use the negative sign for the opposite direction, like this.
Oh,
So we know that 1,000 is greater. So that's why we follow the direction of force B.
yes.
Okay, clear now?
Yes.
Now let's see the question what they are actually asking about. They are asking about the mass of the car. So do you know the basic formula for the weight and the mass?
No.
Actually, this is related to the chapter of weight, mass, and density. So I'm just writing a basic formula W equals to mg. That is not much very difficult, I hope. So this is the basic formula. We will study this formula in the chapter of weight also. And if you need to find out the mass, so m equals to W upon g, right? This will be equal to, now we need to write the value of weight, and weight is equals to 8,000, right? Because in diagram
Yes.
we just mark the value 8,000. So that will be equal to 8,000 divided by 10, because G is given in question 10.
So
And this
the
is,
mass is 800.
yes. So this is the value of mass. And in next part, you need to find out the resultant force on the car, right?
Which one?
Uh,
Oh, okay. So we
Resultant,
found
right?
that out. It was
We already
400.
found it. So you just need to write resultant force will be equal to 8,000. One more concept that I want to clear, that we are not subtracting the forces, right? Because if something is there, so it means there will be a positive value, right? Let's suppose if you have money, so it will be not in negative, right? It will be in positive value, right? Because we have some value. Negative sign in forces always shows you that they are in opposite direction, right? So that's why I used to write plus then minus in bracket. It means it shows this force is in opposite direction, right?
Okay.
Like this. Now you can see that one force is opposite to the other, right? Plus 1000 plus minus 600. So finally, we got the same answer, but important thing is the concept, right? If someone asks you in theory question or someone asks you in the class or anywhere, so you have concept that why we use negative sign, right? Because if you just answer, we just subtract. So they used to ask you that we are just adding the forces, we are not subtracting. So then you will answer that negative sign only shows the opposite direction. That's it. We are only adding the forces or adding the vectors.
Okay.
So 400 Newton is the resultant force. Now acceleration of the car. Okay, so in next question, the acceleration of the car. So we discussed the formula Newton's second law, F equals to ma. So we use this formula F equals to ma to find out the value of force, right?
Okay. Which one will we use? Force B?
We used the resultant force, right? Because question is in continuation.
Oh,
So that's why we use need to use the resultant force because that is the final force, right? Car is moving with 400 Newton in forward direction. So F equals to ma, F is equals to 400, mass is equals to 800. That needs to divide on the other side,
0.5
0 0.5. SI of acceleration,
meter per second square.
square, right? At another time, the car is traveling at speed u. It then accelerates for 5 seconds with an acceleration of 1.6 meter per second and reaches a speed of 20. Calculate the value of u. So how we can calculate this one? This is also very simple.
We will use the final velocity minus initial velocity divided by time, and then for acceleration, we will write 5 is equals to u minus, oh, no, 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 1.6 meter per second.
This is the formula, right? For acceleration. Acceleration is
Yes.
already given. Final velocity is also given. Initial is equals to unknown value because we need to calculate u. Time is 5 seconds. So it will be like 1.6 by 5, uh,
8.
8. Okay. And we just replace these values with u and the 8, right? We just replace these values.
So it's 12.
Well, the per second, right?
Yes.
So you can see that these are not much very difficult concept related to forces. Only now you just need to remember all the things and remember one thing that when we are doing a specific part of question, it's like we started from part B, B1, B2, B3. So all parts are interconnected, right? So try to take the hint from the previous part. Okay.